Hello everyone, we welcome you all to our Mechanism Sessional 5. We have chosen the topic Windscreen Wiper Mechanism as our simulation assignment. Our team members are
Mrinmay Pal 21ME10109.
Arjish Chowdhury 21ME10105.
Subhajit Bhaumik 21ME10081. Moving on to the next part, the problem statement says synthesize and make a simulator for the windscreen wiper mechanism with no quick return effect. In the simulation, mark the area wiped and we have to add any new idea to make the mechanism better. Moving on to the next part, Grashof criteria. So here in this diagram, O2ABO4 is a 4R linkage. So in 4R linkage, as per Grashof criteria statement, if the sum of the shortest and the longest link is less than the other two links, then the shortest link rotates completely. So in the diagram, O2A is the shortest link in 4R chain, and therefore this chain is a crank rocker mechanism where O2A is the crank. Therefore, we can attach a motor at joint O2 and operate it as an input to drive the mechanism. Now displacement analysis. The displacement analysis gives us the relation between the input angle theta2 and the output angle theta4. Taking as the input hinge origin, we find the coordinates of P and coordinates of Q. Now using the distance formula, we find the relation between the links, that is between the length of the links L3, L1, L4, L2, and convert it into a simplest form, A sin theta 4 plus B cos theta 4 equal to C. Now using the half angle formula, we find the angles theta 3 and theta 4. Using A tan 2yx, we can assure the quadrants for the angles. Now I will hand over to Arjish for the next part.
So I'm Arjish Chowdhury and I will elaborate the velocity analysis of this 4R mechanism problem. So as you can see, as the displacement analysis we have found, we can also differentiate this theta 4 with respect to time and find it. So here we have used the instantaneous center method. So basically, as you can see, I12 means the instantaneous center of body 1 and 2. So about this point, the velocity of body 1 and 2 are basically same. So here to find the instantaneous center of I24, we have joined the line joining instantaneous center of 2 3 and instantaneous center of 3 4, and also the line joining instantaneous center of 1 2 and instantaneous center of 1 4. So they are basically meeting at this point C, and this is the instantaneous center I24 about which the velocity of body 2 and body 4 are equal. So here we have seen that PC theta 2 dot equal to QC theta 4 dot. So basically theta 2 dot is basically the input angular velocity, and we have to find theta 4 dot. So we need to find the relation between QC and PC. So here we have used this theta 3 to found this ratio PC by QC. So you can see tan theta 3 equal to L2 sin theta 2 by PC plus L2 cos theta 2, that is also equal to L4 sin theta 4 by QC plus L2 cos theta 4. So here we can substitute the value of PC and QC and find theta 4 dot with respect to the given input theta 2 dot. And also, as we have seen that we are getting two values of theta 4 using this quadratic equation. So we have these are theta for 1 and theta for 2. So like we can put the value of theta 4 in this equation, and we will get the values of theta 4 dot. Now this is basically the acceleration analysis. So as we have got the value of theta 4 dot, we can also write this as theta 4 dot is equal to j theta 2 dot. J is called the Jacobian operator, and now we can differentiate this theta 4 dot with respect to time. So we can see theta 4 double dot is equal to del j by del theta 2 plus del j by del theta 4 into j into theta 2 dot whole square plus j theta 2 double dot. Now we can find the values of del j by del theta 2 and del j by del theta 4 using this expression. Now basically we need to find the area wiped. So as we can see, the angle between the extreme positions of the wiper is 42 degree. That is also equal to 0.733 radians, and the length of the length of the link above the hinge O4 is basically 300 centimeter. So area wide will be equal to 220 centimeter into the angle, that is 0.733 rad, into the length of the link, that is 300 centimeter, that is 483878 centimeter square. So that's how we have found the area wiped by the mechanism. Now we were asked to give some new ideas that can make our mechanism better. So basically, if we increase the length of the wiper, then the area that is being wiped is also being increased, because it is proportional to the length of the wiper. Also, we can basically instead of fixing the wiper, we can make it flexible. So this will change the area wiping orientation of the wiper. So we can wipe the area as we want without any limitation. From here, my friend Mrinmay will continue.
Hello everyone, this is Mrinmay Pal. Now we'll look at a video of the simulation. Now that this is over, now we want to see how we have produced this simulation. We have used a software called Blender in order to create the basic structure of our simulation. At first we have used armatures to create the bones. The bones form the skeleton of this Grashof chain 4-bar mechanism. Now as you can see, this small bone is the smallest link, and hence it is the crank, that is, it can rotate completely when it is connected to the motor. As you can see, it is demonstrated here. Now this is the wiper and this is connected to this big link. Now one must remember that this one and this one is actually the same link with a hinge in the middle. So that means when the crank rotates, the wiper moves from one extreme position to another extreme position. Now for better appearance, we have used cubes to cover these bones so that they look like planar links and with hinges in between them. Finally, we have added the wiper and connected to this big link. Then we have used keyframes to specify the angle at specific points of time in order to ensure the proper movement of the wiper. So finally, when we press play here, we can see that our mechanism is working perfectly. Thank you.